Hey everybody, uh, GCSE Maths today is going to involve doing ranges and averages, some of which you'll already know and some of it might blow your mind, I'm not really sure. So we're going to look at it from the pretty start, so do a quick recap of the four modes of range and average, and then we'll see where they apply in different places. So what better place to make a start than right here. So I there's four statistical operations, and I best tell these in a story about competition. So the world was set in a competition where they were asking for the best form of average, and so the greatest minds of the world got together in the different fields uh, and realised that they'd have to use maths to do it. So some of them were stronger at maths than other ones. First guy up was Dr. Mean, and Dr. Mean was pretty good at maths, and he thought, well, this is quite easy. The best way to get an average is to take all your values and add them together and divide by how many there are. That's obviously going to give you the best average. And away he went, very chuffed with himself. That was all well and good. Dr. Mean was a scientist. He was, but his maths wasn't a strong part of his of his science. So he decided that well, Dr. Mean's got that maths thing well covered, there. But to me, he's got a bit of a flaw in his argument. Surely if I put them in order from smallest to biggest or biggest to smallest one way round, and I find which one's the middle, then that'll be the best average. And away he went off. I got this competition sorted. That's okay. Dr. Mode came along, and he was a psychologist, and you know he stopped doing maths a long time ago, and he decided, well, look at those guys. They've got it going on with their maths. I just think, if something happens more often than the rest of them, then if it happens more often than the rest of them, then it seems reasonable to me that that would be the best form of average. That was good. And Doctor Professor Range, sorry, should I say, Professor Range comes in the back and says, the only thing I can remember doing from school is subtraction, and I'm pretty good at it, really, really good at it. So what I think we should do is we take the biggest value and the lowest value, and we'll take those two away from each other, and that will be our form of average. And the other guy's saying, well, that's not really giving an average, but I like where you're going there. That's pretty good. So that's the story. In actual fact, all the mean, median, and mode are all considered good forms of average, and we'll come on to later about how some of them are best used in certain situations and other ones. The range is an important statistical measure as well, but again we'll come to that. So we'll look at the mean first of all. It's the most commonly known form of average. So when people say about, I'm going to find the average of those, they're usually talking about the mean. And the basic idea is you add your values together and then you divide the total by the number of values or the amount of values that there were. I'm trying to be very careful with my language here. So amount is the amount of them rather than using the word number all the time. So if I give you an example, here's an example of math scores in the class. So one person got 82, one got 93, one got 86, 97 and 82. If I add up all those numbers together, and you can pop them into your calculator if you want, you will get 440. And the second part of the mean is that you divide that total by the amount of values, and there are 5 test scores there in total. So if we divide that total by 5, we will get 440 divided by 5 will give us 88, which is great. So the mean test result in that case is 88. Great. Next one, the mode. Known as the most common value or the most common category within things, it is important to know that in many cases this can be a form of qualitative data, i.e. a word. An example being, what's your most popular type of pizza topping? You're going to tell me pepperoni, you're going to tell me, ham, you're going to tell me bacon. You're not going to say pineapple, because pineapple's the wrong answer for popular pizza topping. It's a fruit. Other examples will be, what's your favourite colour dress? Applicable to some in the class more than others. I particularly, red or black person if you ask me. But that again would be a word. But in the example I'm going to give you, we're going to stick to numbers and show you how it works in numbers. So again, if we use the same sample of math scores in the class, you've got 82, 93, 86, 97 and 82. The most common score is 82 as it appears twice. So it appears more often than all the rest of them. Therefore, the mode or modal value is 82, and it's sometimes called modal value, and that's the mode. Next, median is the middle value. forgive my air quotes there. Put your values in order from smallest to biggest. And then find the middle value. Now, if you have an odd amount of values, say 5 or 7 or 9 or 11 or 13 or whatever, you'll only find one number in the middle in that case. However, if you have an even number of values like 2, 4, 6, 8, 10, 12, etc., you'll find two numbers in the middle. And in that case, we'll find the mean of the two numbers it says here. So if I give you an example, and I'll give you one of the harder examples, so one with 6 scores within the class, and there they are there. We have to first put them in order. So if I put them in order, we get 72, then 83, then 86, then 88, 92, and 94. We'll find the middle value. So there's our scores. And we'll stroke one off from the start and one off from the end. Like that. One off from start, one off from the end. And you will get your two middle values to be 86 and 88. We find the mean of the two numbers by adding them together and dividing by 2. So we take our 86 and 88 and add them together, get 174. And then we take our 174 and divide by 2. It gives us 87, and that is our median. Last one is the range. It's not really a form of average like the other ones, but it's still an important form of interpreting numbers or interpreting statistics. So the range describes how wide the range of values are. Just can't help myself using the word range. How wide the values are spread. So in the example, here's a sample of math scores. There's your 5 scores again. The highest value or the biggest value is 97. The smallest or lowest value is 82. So the range is the difference between the two values. And as you know, to find the difference between two values, you just take them away. So it's 92 minus 80, 97 minus 82, which is 15. Okay, here's your challenge. I'll pause the video after each section. So give me 5 values which would give me the results of a mode of 15. Give me the 5 values with a median of 17. So a mode of 15, sorry, should I say. Median of 17 is the second one. 5 values with a range of 20. And 5 values with a mean of 12. Now I'm going to make that part of the homework down below, so you can pop in your answers there, and we'll see how you get on. Now, appropriate average. I'm going to spend more time on this in class because this is the category of statistics and average that is generally reserved for A and A star grades. So it's very much a higher tier bit only. So I'm going to give you some examples in class depending on whether it's relevant to you or not. But sometimes one of the averages can be a better form of average than the other. So the example that I use when doing this is, consider going to Tesco's. You go to Tesco's one week and you buy your loaf of bread, you buy your pint of milk, you buy your packet of cookies, you buy your packet of ham. You go up to the counter, you pump them all through, and you're trying to work out what your average value or average spend is. Average spend is probably the wrong word, but your average, best form of average for those can be. Now, if you think about the value of each of those items, they're all roughly between £1 and £1.50. And if I get an average of say £1.20 or £1.30, that is a good approximation of what the average spend of what you did was. So it talks to what most of your values cost. However, if you go back the same week and go in and buy your pint of milk, your loaf of bread, your packet of cookies, and your packet of ham, and this week you go in and buy a TV as well out of Tesco's, that's on special of £500. If I use your mean to calculate that, you'll have £1, £1.50, £1.20, whatever, and then £500. When I work at the mean of those, it would be roughly about £100. Now that doesn't represent anything of what I bought. You know, there's nothing of my value cost £100. More appropriate average in that case might be the median, where you would put them in order from smallest to biggest and still get your value to be around £1.20, £1.30. But you would qualify that by saying, however, this week I bought a TV which you know doesn't belong in the normal weekly shop, if you know what I mean. So be careful about that. That's my introduction to it. We'll discuss it more in class, and it's some people can find it pretty tricky to do. But if they can think about exactly what's happened to values, and if there's real values within that are knocking it way out, then that can be the reason why you choose another form of average rather than another. And that's appropriate average. So there's your shopping story. So with no TV, you generally find that the mean is, if the values are all around the same, the mean is a good form of average. And in the TV part of my story, if you're talking about your average weekly shop, you'd probably talk about the median then, because you would have that TV would knock the price out for that 1 week you went and bought it. Okay, so rolling back to stuff that we did in previous week, how do we find average from stem and leaf diagrams that we did last week? So here's an example. There's a stem and leaf diagram with 6 values in it, and we have to calculate the mean height of these plant seedlings. Now, 6 bar 2 is 6.2 centimeters. How would they calculate the mean? Well, there isn't an easy way to do it using stem and leaf. You would just take your values and add them together and divide by 6 as there is. So your 6 bar 2, your 6 bar 3, 6 bar 3, 7 bar 2, 8 bar 2, and 9 bar 0. Add those together and then you divide by 6 and you will end up with a 7.2 as your mean. What about the median? Well, in the median there are 6 values. So again, you can stroke one off from the end, one off from the start, until you get the 2 middle numbers. And the 2 middle numbers will be 6.3 and 7.2. Because there's 6 numbers, you're going to have 2 middle numbers. That's an even amount. So you'd add those two together and divide by 2, and you get 6.75. And if we work at the range, it's probably the easiest part of it. The biggest number is 9.0, and your smallest value is 6.2. So if we take those two away from each other, the range is 2.8. And we'll do some more examples in that in class. Good. What about finding an average from frequency tables? Right, so in this experiment, the results from rolling a 6-sided die were recorded. Work out the range, the mode, and the mean for each of these. So the table says that we rolled a 1 12 times, rolled a 2 15 times, a 3 8 times, 4 22 times, etc., etc. So we'll consider what that would look like without the table. If we would record that data without a table, you would record a 2, a 1, a 2, a 4, 2, 1, and make a big list. And then you would group that table into group that data into a table, whether you recorded it in a tally chart or whatever. So if I do that, the first thing to look at, we're asked for the range. And the range is nothing to do with the frequency amount of times. You're asked for the range of values that could be happening. So the values that we're recording are either, as you see before, are a 2, a 1, 2, 4, 2, 1, 3, 5, etc. We're recording the score in the dice or in the die. So the range is only going to take that into account. So if we look at that, the range, the biggest value I have is 6, the smallest value I have is 1, and you get a range of 5. It's a very common mistake for people to take 22, take away 8, because they're looking at the range of the frequency. But again, if you look back at what we were actually going to record without the table, it would have been just the values in the dice, not the amount of times that each happened. Okay, so if we're looking for the modal score, this is going to be the score that happens most often. If we look at our table, the modal score is 4 because we got a 4 22 times, which is more times than anything else. And the last one's the median. And the median, first thing we need to do is work out the total number of times the dice was rolled. So if we got a 12 ones and 15 twos, etc., we'd add those values together. So with 12 times we rolled a 1, 15 times we rolled a 2, 8 times we rolled a 3, 22 times we rolled a 4, 16 times a 5, and 20 times a 6. If we do that all together, we work out that that was 93 times in total. Now the next bit's a wee bit confusing. So we're going to find the middle value. Now the classic form of the middle says that you do n plus 1 divided by 2. Right, so you take your total number of times you roll it, add 1 to it, and divide by 2 equals 47. In most cases in the exam, if you take your thing and divide it by 2, if you take 93 and divide that by 2, you're going to get 46.5. So your median is going to be the 46.5 value. Now, you can do the n plus 1 divided by 2, and I will show you that when we're doing it in class, but if you're struggling with that bit, just divide it by 2. You know, find your total number of values and divide it by 2 to find your middle number, if you know what I mean. The reason it's n plus 1 divided by 2 is because if you think if you have 5 values, right, you stroke one off from the top, one off from the end, keep doing that, you're going to find that the third value is the one that works. So if you do 5 divided by 2, you'll get 2.5. But if you do 5 plus 1, 6 divided by 2, you'll get that middle value. That's the reason it works. But if you struggle, that can be a very confusing thing to do. And in most cases, I can't think of a case where it hasn't helped in this case. You divide it by 2 and find roughly even 46.5. You will get the answer. So if we look at that, the median ends up to be 4. But why? Well, we're looking to see where the 47th value falls. So if I look at 1, and looking at like a cumulative frequency graph, which I know we weren't doing until next week, but we did them last year as well. By rolling a 1, we use 12 values. By rolling a 2, we use 12 plus 15, so that's 27 values altogether there. If I add another 8 to 27, I'm going to get 35. And if I add 22 to 35, I'm going to get 57, right? Now, 57 is way over the 47th value, and 35 is where the end of the third one is. So the third 47th value is going to fall in the middle here somewhere, and so will the 46th and a half value as well. So that's where it's going to fall, and that's why we say the median is 4. Now, the important thing to notice in all these questions is the answers were all dictated to by the scores of the die and not by the frequency. Very, very important that you remember what it is you're recording. You're recording the numbers that were on the die rather than the amount of times that it happened. We use that information when we're grouping it, but not when we're giving our answers. Okay. What about if we're asked to find the mean from a frequency table? Okay, so the frequency table shows the number of goals that teams scored in each match for one season. How many matches did the team play is the first question. Work out the total number of goals scored in the season and calculate the mean number of goals scored per match. Okay, so the first one, how many matches did the team play? Well, again, think about what you're recording. You're recording about the number of goals scored over a number of matches. So in the first case, there were 8 games where they scored no goals. There were 15 games where they scored 1 goal. There were 12 games where they scored 2, 7 games where they scored 3, 3 games where they scored 4. So the number of games they played is the frequency in this case. So if we're looking at the total number played, we would add together the 8, the 15, the 12, the 7, and the 3, and that would give us 45. If we're working out the total number of goals scored in the season, then what would we do? Well, if there's 8 games where they score no goals, in those 8 games they scored no goals. If there's 15 games where they scored 1 goal, in those games there's going to be 15 times 1, which is 15 goals scored. In the next one, there's 12 games where they scored 2. It's going to be 12 times 2 is 24, etc., etc. And what you do is you add a column to the right. And when you add the column to the right, you will find those values there. So you're multiplying the number of goals by the frequency. And if you add those all together, you get that the team scored 72 at the bottom. So if I do 0 plus 15 plus 24 plus 21 plus 12, you'll get that. Okay, just like here, there were 7 times that the team scored 3 goals, so that would be 21 goals for that whole category. Okay, we have to calculate the mean number of goals scored in a match, and to do that, we use the total number of goals, which is that, divided by the number of matches. So mean number of goals per match, remember per unit gives you a divide. Per in maths means divided by. So number of goals, which is there, per match, and the number of matches is there. So 72 divided by 45 equals 1.6. Now, if you did some other combination of numbers within that, you would look at your answer and go, does that make any sense to me? If you got 14 to be your answer, or 9 or something, well, they didn't score 9 goals per match in any game, so that doesn't make any sense. So think if your answer makes some sense when you're going through it. What about group frequency table? So the basic idea is the same as what you did before. In this case, you worked out your number of goals times your frequency. So we'd write down the modal class, work out the range, and which class contains the median, and then in the next example, we'll work out the mean. So the modal class, again, is the most common class that there is. And the most common class is a height between 5 and 10, or greater than or equal to 5, less than 10. There's 14 of those. So that's that. Ooh. So that's modal class. If we're working out the range of the data, well, the very top of the data, the top it can be is 25, and the lowest it can be is 5. So the range is going to be 25, take away 5 is 20. Now, it says estimate the range. The reason for that is because we can't really know what the top value of that data is. It could be 23.6, meaning it could fall in there. It could be 20.12, could be even as low as that, as long as it falls in that kind of class there. We know there's just 2 values that fall in that, but we don't know what they are. So we can only estimate that, and the only information we have to estimate is that top bit there is 25. The bottom bit of the whole thing is 5, so the range is 20. Like so. We have to, which class contains the median interval? So again, as before, you would add up for 14 plant seedlings between 5 and 10. There were 11 between 10 and 15, 8 between 15 and 20, and 2 between 20 and 25. So if I add those values all together, 14 plus 11 is 25, plus 8 is 33, plus 2 is 35. 35 plant seedlings, you can use your n plus 1 divided by 2 to give you 36 and find that the 18th value is the one where the median is. Or you can just say 35 divided by 2 will give me 17.5. So the 17.5 value is roughly where we're looking for. We find the class. So that one's 14 up to there. That one's up to 25. So the median value is going to fall after this one, but before we get to that one. So it's going to be within 10 to 15. Okay, so where does the 18th value fall? Well, the 17.5 value fall. It'll be in there. Okay. What about the mean? So if we look at the frequency table showing the heights of trees in a park, work at the midpoint of the class interval, calculate the total height, and calculate the estimate for the mean height of the trees in the park. Again, we'll have our class, so there's 10 trees that measure between 0 and 5 centimeters. That doesn't seem very big, does it? Oh well, it'd be much better if it was meters. It'd be a much more impressive park. There's 18 trees measured between 5 and 10, 10 and 15, and 15 and 20. Okay, so the midpoint of the class interval. We did this last year. So what you would do to find the midpoint of the interval, midpoint of the class, is you would take your bottom value and your top value, add the two of them together and divide by 2, a bit like finding the mean of the two. And in this case, between 10 and 15, you take your 10, add your 15 to give you 25, divide that by 2 gives you 12.5. So the midpoint of the class interval between 10 and 15 is 12.5. Now, like we did this last year, what you're going to end up doing is adding two columns to your table. So it's asked you to estimate the total height of all the trees in the park. So if we're looking for all the total height of the trees, we need to do this bit here. We need to work out midpoints for our whole ranges so that we can say that if we take our midpoint, say the 10 trees that were roughly or on average 2.5 meters in height. See, that did change. Before they've got the height in centimeters, and now it's in meters. That makes some sense now. There you go. So there's 10 trees that measured roughly 2.5 meters. There's 18 trees that measured roughly 7.5 meters, and there's 6 trees that measure roughly 12.5, 2 that measure 17.5, etc., etc. And if we can do that, if there's 10 trees that measure roughly 2.5 meters, then that gives us those 10 trees roughly were 25 meters tall. Those 18 trees were 18 times 7.5 or roughly 135 meters tall. Those 6 trees are roughly 12.5 meters tall, give us 75, and same for the last. And if we're asked to estimate the total height of all the trees in the park, then we can add up all those values at the end, the 25, the 135, the 75, and the 35. And that will give us an estimated total height of all the trees in the park to be 270. Now, much like before when we did about the goals, the mean is calculated by doing the total of the midpoint times frequency column divided by total frequency, or the total height of all the trees divided by the number of trees. We looked at it last year, and I give you the formula sum of fx over the sum of f. But it's roughly exactly the same thing. So if you're looking at the graph, that's your f, and your x is your midpoint. And so fx is equal to f times x, so it's midpoint times the frequency times the midpoint. Sum of fx is the sum of all the values in the fx column, and the sum of f is the total of all the values in the frequency column. That was the old maths text speak, if you know text language, using Greek symbols. Just love it, love it, love it, love it, love it. But I broke it down the other way, so it's midpoint times frequency, that total, divided by the total of all the frequencies altogether. And if you do that, you get 7.5. 270 divided by 36 gives us 7.5. And we'll do lots of examples of that again in class. We have lots of them to work out. So, key questions to get yourself organised. It's easy to get yourself confused by so many permutations of working out range and average, etc., etc. So you want to organise it for yourself in some way and ask yourself some questions when you come to it. Is the data grouped or not grouped? If it's grouped, we're going to use the midpoints and the frequency for the mean. So you'd have the 2 extra columns at the side where you'd work out your midpoint and then your frequency, your mean. If it's not grouped, you're just no midpoints needed. It's just your frequency times your group. So if you think of the number of goals scored, it was 4 games with 1 goal, for instance, which would give you 4 goals. That's the question to ask yourself. Is it grouped or not grouped? And then you'll work out what columns you need to do. The method after that is pretty similar once you practice it a bit, but that's what you want to do. And that's the end of today's lesson. Sure, you'll have loads and loads of questions, but bring those with you. They're the bit that's really important from watching these. Watch these videos, find out what you don't understand so that I can really get to you, or use the people in the room that did get it to help teach you. You know, I say it all the time, the peer teaching of other people in the class is so important to your knowledge within the class. And if they can't help, I'll get round and get you help, but I can help you in smaller groups then. Okay, so bring your brains. Don't get annoyed about it. There's quite an awful lot in today's lesson, but hopefully you picked up enough to be able to bring that with you. There's homework below for you to try. Give it a go. And I'll see you in class on Tuesday. Good luck with it. If you need me, get me either at FlipMath or by email. Okay, thank you very much. Speak to you later. Bye.